Okay, currents, forces and forces on magnetic fields. Here we go. So, we have a wire that's 0.173 meters long. We're told the magnetic field, use the letter B for magnetic field. The magnetic field on it is 0.47 Tesla and the force on the wire is 0.089 newtons. And we have to calculate the current in the wire. No problem. So it tells you to use the sheet from your formula. You don't even have to remember it, but you should know it anyway. The force on a current carrying wire is Bil. B-I-L. Okay? That's the equation we're going to use. We have to find the current, which is I. So rearrange this equation to make I the subject. Divide both sides by BL. And we get I is F over BL. Always rearrange the equation first. Make the thing you want the subject and then put in the numbers. Don't put in the numbers here, then rearrange it. That's a pain. Do it like this. Right, we're ready to put in the numbers. So therefore, current is, the force is 0.089. B is 0.47 times L, which is 0.713. All of them are in the correct units, meters, Tesla and newtons. Stick that in your calculator and you get the current to be 0.26558 something something something. And it says give your answer to an appropriate number of significant figures. I would say 3 significant figures because in the question they've given the distance to 3 significant figures. Yes, the B field is to 2 SF and so is the force, but that is 3 significant figures. So we should give our answer to 3 significant figures. I was always taught that you give the answer to the same number of significant figures as what they're using in the question. Okay, so if I was in the exam, I'd say I is 0. So we go into there, that 5 pushes that up to a 6, 0.266 to 3 significant figures. Okay? That's the correct answer. Good. However, looking at the mark scheme for this question, we have problems. The mark scheme for this question, Edexcel, is a train wreck. Okay? Firstly, Edexcel rearranged this formula incorrectly. They had the L on the top, I think, or the B on the top. That's correct, okay? Secondly, they say you should get 1 mark for giving this to 2 significant figures, which would be 0.27, okay? As far as I can tell from the mark scheme, they wouldn't give you a mark if you gave it to 3 significant figures, which I think is correct. So Edexcel, sort this out, okay? Edexcel, if you're watching, I think you should give a mark for giving it to 3 significant figures or 2 significant figures, okay? And I hope that's what you do in the real thing. Right, you've been told. So, students, I'd hedge your bet. My advice, because the mark scheme is not clear, okay, I'd give it to 3 significant figures and I'd also give it to 2 significant figures. Okay, 5, 6, push that to a 7. And I'd actually write the reason you're giving both. You'd say, well, in the question you've put 3 significant figures there, but in previous mark schemes that I've been looking at, because I've been working hard for my exam, you've marked it to 2 significant figures. Okay, yeah, anyway. So, yeah, I put both in the real thing. But I really hope that Edexcel give you a mark no matter which one you put. Okay, let's move on. Rant over. Okay, next bit we have this experiment here. So what we have is a copper wire here, the blue bit. A copper wire is stiff, okay? So you've got a stiff wire attached to a stiff piece of plastic. So the whole thing acts like a rocker on these pivots, okay? We're sending current through this wire and it's sitting in a magnetic field provided by the magnets. So according to the equation, force is BIL, this wire will feel a force. It feels a force upwards and pushes this plastic piece, and the force meter feels a force downwards. And the student records the readings on the force meter for different numbers of magnets. And the student finds that something needs to change because these numbers are not great. So the student decides things are not sensitive enough, and he's right. And we have to give 3 ways the student should develop his investigation to improve the quality of his results for 3 marks. Okay, no problem. Well, I've already mentioned the force experienced by this wire is according to the F equals Bill equation. So write that down first, okay? F equals B I L. And just write a little sentence saying the force experienced by the wire is according to this equation and therefore depends on the strength of the magnetic field, the current and the length of the wire. Okay, and there's our 3 marks. To increase the force, we have to increase that, or that. Or all 3. Okay, so 3 things, 3 marks. So let's rattle through this. So the first thing to do is increase the magnetic field, which means increasing the number of magnets. So increase magnetic field, or increase number of magnets. Okay? Which will therefore, according to the equation, increase the force experienced by the wire and therefore the force experienced by the force meter. Okay, next one. Increase current. So increase current, which means increasing the voltage. Okay, or greater number of cells or stronger batteries, something like that. Okay, which again, according to the equation, will increase the force. Length for our 3rd mark. Increase the length of wire in the magnetic field. Okay, 3 marks. But you can say more if you want, and I encourage you to do so to absolutely nail it in the exam. You can also say, yeah, more sensitive force meter. Okay, more sensitive force meter. And finally, you could also say, by the way, in the exam, don't write these dots. I'm just doing that to lay it out. But you should write nice sentences and paragraphs. Okay. Finally, we want to increase this length here from the pivot to the wire in the magnetic field. So increase the copper wire, the wire length from pivot to magnets. Okay, because that will increase the moment about pivot. That increases the moment. It's a moments thing, which will lead to an increase of the force experienced by the force meter. Okay, the force here will remain the same, experienced by the wire, but it's moments. Moments is force times distance to pivot, perpendicular distance to pivot, in fact. So if that force is the same, but this distance to the pivot increases, the moment increases, so we get a greater force experienced by the force meter. Good, definitely got 3 marks for that. Okay, let's move on. This thing next. Now, we have 2 different graphs showing how voltage changes with time. Here and here. And we have to explain which of the voltages causes an alternating current for 2 marks. Okay. Well, they're both going up and down like that, so they're trying to sort of trick you here a little bit. This looks like the same sort of shape that your teacher's always drawing for an alternating current, right? So they're trying to sort of trick you into saying this one maybe. But it's not that one, it's this one. This one is not an alternating current. I know it goes up and down like that, but the reason it's not an alternating current is it never dips below zero. The voltage has to change direction, not just magnitude, for it to be an alternating current, okay? It changes magnitude. It's going up to about, I don't know, 12 volts and down to about 8 volts. So it's going between 12 and 8 volts. But it's never negative. It never changes direction. It's always in the same direction. And therefore the current will also be in the same direction because the current depends directly on the voltage. Okay, so that is not alternating current. Believe it or not, it's direct current. It's very clear. It's direct current, okay? This one is alternating current because the direction of the voltage changes. It's positive here, and then it dips below zero. It goes into the negative region, so it changes direction. Positive, negative. This one is always positive, okay? Good. So for 2 marks, what would you say in the exam? Say that an AC, an alternating current, its direction must change, okay? And therefore, well, for this one only, so for this one only the magnitude changes, but for this one the magnitude and direction changes. Therefore it's AC. Okay? I don't think I've missed anything. You definitely get the 2 marks for that. Oh yeah, you could also say, I said out loud, but the current depends, because it's alternating current. These graphs of voltage, yeah, it's true. You should say that the current depends directly on the voltage. Okay? If no harm in writing down V equals IR. See, voltage is proportional to current. Good. Okay, I'm really going into detail here, but it's fine. Just for total, so covered everything. Direction, you could say that the sign of the voltage changes. Positive to negative. This is positive, this is negative. Okay. Good. Definitely got 2 marks. Right. Last thing. Shall I have a change of colour? Yeah, why not? Let's go pink. So, last question. A power transmission wire hangs so that it is at right angles to the Earth's magnetic field. Although this magnetic field is constant, the cable experiences a changing force. Explain why the force experienced by the cable changes. 4 marks. Yeah, okay, so we've got, you know, the power transmission lines that those ugly things you see in the countryside with the, carrying the wires like this, carrying the whole, well, the wires hang from them, they carry a current. Okay, well, these things, the key to this question is that these things carry an alternating current, okay? So that's the key to this whole question. In power transmission lines, so that's the first thing we'll say, in transmission lines, they are alternating current, okay? Very important. Okay, now, you have to repeat yourself. We've covered it in this question here, but you have to say it again to get the marks in this question. Alternating current changes magnitude and direction. Okay? Next. Same stuff again, isn't it? It's write down the equation F equals BIL. The force experienced by the transmission wires goes according to the equation BIL. Okay. Now we have an alternating current. Therefore, so we have AC. Therefore, talk about direction first. When current changes direction, the force changes direction. Okay, and remember the question asked us, explain why the force experienced by the cable changes. So the force experienced by the cable changes, that's all it said. So that means changing magnitude and changing direction. Okay, so the direction changes, we say exactly the same thing for all the marks. It's alternating current, therefore current changes magnitude, therefore the force changes magnitude. Okay, 4 marks in the bag. Good. I think that's everything. Yeah, that is how you would extract 4 marks from that question. Right. Another exam technique-y question where you have to constantly extract the maximum number of marks using explanations and descriptions and things like that. So there we go.